All right, now when you look at this problem, you've got a bowling ball that's going back up to the ball rack, and it has it's moving with a certain speed. Translationally, it's also rotating. It's going to go up here, which is at a higher potential energy, so it's going to lose some of the kinetic energy that it had here, whether it's translational or whether it's rotational. Now, if you look at the problem, it says if the translational speed is 3.5 meters per second at the bottom, the question is what's the translational speed at the top? Now, I might have on the test, if I have this problem, just to throw a little wrinkle into it, I might give you the translational speed here and ask you to solve for it there. Okay, so either one of these could be given and the other one could be the unknown. Well, in solving this, we're going to do this as a log conservation of energy problem. We do know the height is given in the problem as 0.760 meters, so I can figure out if this is my starting point, I can call my potential energy 0 there, and that's going to be at some higher energy there. So my equation, and there's no work being done in going from here to there. Now, there are two types of work. You could have force times distance, which would be changing the translational energy, or you could have torque theta, which I really didn't go into, but work for rotation is torque theta, just like work is force times distance. The corresponding variable for force is torque, and for distance it would be theta. So you could actually have rotational work in a problem. So in this one, though, I'm going to begin with KO. Now, we've got two KOs. We have translational and rotational. So I'm going to write I'm going to write KOT plus KOR plus UO. I'll put W in. I know it's 0, but I'm just going to put the whole equation. Equals KF translational plus KF rotational plus UF. So there's my generic equation. Now, if I'm looking at this, what can I make 0 here? UO, because the low point is there. So I can say UO is 0. What else is 0? What? W is 0 because there's no work in going from the original to the final position. And so I think that's pretty much what we have right here. So we've got, because we're going to have, it's probably still going to be rolling and it's still going to be moving when we get to there, and it's at a higher level. So at this point, I'm going to replace my translational kinetic energy with 1/2 mVO squared. Now I'm looking at the problem, and they didn't give me the mass of the bowling ball. So it's probably going to be where that's not going to matter. So we're going to have 1/2 mVO squared. It's probably going to cancel out of every term. Now for kinetic energy, I'm going to have 1/2 I omega original squared. And really the I could also change, but in this example it's not going to change because it's a bowling ball. The bowling ball's not going to change its mass as it's rolling from its original to its final position. So we've got that. And then on the other side, we're going to have 1/2 mVF squared plus 1/2 I omega F squared plus mg times the final height. Now at this point, I've got m's and i's and omegas and v's. I've got a lot of stuff here. Remember I told you that you can always write a 1/2 I omega squared. I can write this in terms of m and v. So now I'm going to replace the I and the omega so that every one of these terms has an m in it and a v in it. Well, other than the potential energy, but every one will have an m. So the next step is I'm going to just copy down this. I'm still going to get 1/2 mVO squared. Notice I'm not worrying about numbers yet. I just want to, I'll get the answer at some point here. So I'm going to have 1/2. And now for I, a bowling ball. What type of shape is a bowling ball in terms of how we're going to calculate its moment of inertia? What would you call it? Sphere. It's a solid sphere. And the formula for a solid sphere is 2/5 mr². So that's the formula for I for a solid sphere. And V, I'll do it up here. You remember V is r omega. So since I want to replace omega, omega would be V divided by r. So I'm going to replace this with VO over r squared. On the other side, I'm still going to have 1/2 mvf squared, and I'm going to do the same thing with this term as I did with this term. So I'm going to replace the I and the omega. So I'm going to get 1/2, and then we're going to have 2/5 mr², V final over r squared, plus mg final height. And notice there's a mass in every one of these terms. So I'm going to cancel the mass out of each one of them. That's why they didn't bother giving me the mass of the bowling ball, because it factors out in this problem. It doesn't matter what the mass is. So the mass cancels out there, 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 and there. Also, over here, I have 1/2 and 2/5. So the 2's I can cancel out, and I'm going to get the 2 will cancel out with that 2, and it will also cancel out over there. As far as the r's, the r² will cancel out with the r², but I can't cancel the square because it still has to square the VO. So on the other side, I'm going to cancel out r² with that. And actually, let's take care of something else at this time. I can see that I still have fractions because I have a fraction over here, and I don't like fractions if I know I'm going to be doing algebra and moving things around. So at the same time, even after canceling all these things out, I don't want to write them down over and over and over. So I'm going to take the whole thing, and I'm going to multiply by the least common denominator, 2. So what I'll be left with is the 2 will cancel the half, and I'll have VO² plus, I'm going to get 1/5. Oh, I'm sorry. Oh, I messed up here. Let's start over. Least common denominator is not 2, it's what? 10. So I need to put 10 here. So I'm going to get, so now I'm going to distribute 10 to each one of these. So I'm going to get rid of the fraction there. I'll get rid of the fraction there. I'll get rid of the fraction, get rid of the fraction. There's no fraction there. So every term is going to get multiplied by 10. So I'm going to get, with the first term, I'm going to get 5 VO² plus 2 VO² equals 5 VF² plus 2 VF² plus 10 GHF. And I can combine like terms. So on the left side, I'm going to have 7 VO² equals 7 VF² plus 10 GHF. The unknown in this problem was what? VF. We know the VO, and we know the height, and G is a constant. So all I have to do is rearrange the equation to solve for VF. So what I'm going to do is I'm going to move this term to the other side, which would make it negative when I move it over, divide by 7, and take the square root. So I'm saying that because I don't want to do all those in 3 different steps. What I'm going to have left is that VF is going to equal 7 VO squared minus 10 GHF over 7. Now that would equal VF squared, so I'm going to have to take the square root of that. And that's going to give me the answer for the final velocity. So again, a lot of algebra, but not really a lot of heavy physics. It's just, a lot of this stuff cancels out. So I'm going to get 7 VO squared minus 10 GH all over 7. And that'll get you the answer. So the VO, what was the VO in this problem? 3.50. So 3.50 meters per second. The G is 9.8 meters per second squared. And what was the height? 0.760? 0.760 meters. And solving that. So, sort of a lot to write down compared to other problems we've done in the past. But remember, when you put this in your calculator, go that times that squared minus that times that times that. Then make sure you hit equals at this point, so that your calculator knows that the 7 is dividing the whole thing, not just the second term. So once you put this whole thing in, equals divided by 7 equals square root of your answer, and hopefully you get the answer that I gave, which was 1.27. So the only twist that I could give you in solving this is, instead of giving you the original velocity where you solve for the final, I could give you the final where you solve for the original. And actually, if I did that, the math would have been slightly easier, because all I would have had to do was just move the 7 to the other side and take the square root. I wouldn't have had to move this term to the other side in order to solve for VF. So either one of those can be the unknown. All right, any questions with that?